Hi, this is Mrs. Clark, and I am working on lesson 1.2, Flipping Ferraris. We are on number 6, and in this question, we are going to work on deriving the equation of the function s of d, meaning speed based on distance. That gives the speed of the car was traveling for a given braking distance. So we were originally using this equation. Distance equals 0.03 times speed squared. But what we want to do is rearrange or derive. So this word derive means to come up with an equation for the speed based on this relationship we have here. And so to derive it means we have to take this and kind of rearrange it so that it's s equals instead of d equals. The way we're going to do that is we're going to think about order of operations. So we want to think about what is happening in this equation. So what is happening to the s in this equation? Well, I see this little 2 up here, and so that means it is being squared. So I'm going to write being squared. What is the inverse of being squared? Square rooting. Square rooting is the inverse of squaring. So inverse of that is square rooting. Being squared is something that looks like this. Square rooting is this symbol. All right, what is happening next to s? So s is being squared, and then it has this number 0.03 in front of it. So what is that doing to the s squared? It's next to it, and there's nothing between it, which means it's being multiplied. So the next thing is happening that we are multiplying s by 0.03. So what is the inverse of that? The inverse of multiplying is dividing. So dividing by 0.03. Now we're going to apply these ideas of inverses, of undoing. So this inverse here and this inverse here. But we have to apply them in the reverse order. So it was being squared and then multiplying by 0.03. We need to do the reverse, start down here and divide by 0.03, then go up to here and do the square rooting. And we're going to apply all that to d. So we're going to start with d, our distance. And we're going to divide it by 0.03. So that's this line means divided by. And then whatever we get from doing our distance divided by 0.03, we then have to square root. So square root goes over that whole thing, because we're square rooting whatever the answer is from dividing our distance by 0.03. And that's going to be equal to s of d. So if I want to know the speed, but I have the distance, I'm going to put my distance here, divide it by 0.03, and square root my answer. So this formula gives us the speed if we know the distance. This formula up here, if we know the speed, we can calculate the distance. So it's depending on which one you know will be which one you use. So our next task is going to be to create a table that shows the speed the car was traveling, s of d, based upon the braking distance, d. So based upon right here gives us the idea that it's going to be dependent on this, which means that's our independent variable. So d, distance, is our independent variable. And we need to calculate the speed based on distance. So that's going to be our dependent variable. If I keep reading here, it says include values when d equals 0, 100, 200, 300, 500, 800, and 1,000. So right here are the numbers I need to fill in my table here. So 0, 100, 200, 300, 500, 800, and 1,000. Then we have to calculate the speed. So we're going to do that by putting our distance, so whatever our number is over here, into this formula and calculating what the speed is. So if you grab your calculator, the first thing we need to do is start typing in this function. We can do all of this in one step in our graphing calculator. If you're using one of the blue calculators, you kind of have to do things separately and in 2 steps. But if you do it with this calculator, we can put all this in at once. First, we're going to start with our square root. So second button, and then our x squared button to get the square root. Then we have to put in our distance. So if I start with 0, I'm going to put in 0. Then I'm going to do divided by 0.03. And notice how all the square root kind of stretched out, so it's over everything. That's perfect, exactly how I want it. Then you're going to hit enter. So when the distance is 0, the speed is 0. That kind of makes sense. If you're not driving any miles per hour, you're not going to need any space to brake. Let's do one more with 100, and then I'll let you do the rest. So second square root, and do 100 divided by 0.03. And we get 57.73502.692. Do this with me in your calculator. Pick up your calculator, type this in, make sure you're able to get 57.735, blah, blah, blah. When I write down my speed, I'm going to keep this number, but I'm not going to write all the decimals. I'm going to cut it off at the 73 mark, but I have to look after the 73 and see what there is. Does it stay 73 or does it go up to 74? So rounding rule says if the number after is 5 or more, we're going to round it up. So since there's a 5 after this 73, then I'm going to round this up to 0.74. So 57.74. So make sure you can do that one correctly in your calculator, and then go through and do it for 200, 300, 500, 800, 1,000. Pause the video. When you're done filling out your table, think about what you want to do for your scale, which one goes on which axis, set up your graph. If you need help setting up your graph or want to check your numbers for the table, unpause the video, look what I got, make sure we have the same answers. Then I'm going to go through setting up the graph. If you feel like you're good with that, you can fast forward through it just to make sure our graphs look the same, etc. Here is the outputs that we got. I also threw in the maximum speed that we knew was 217 with our maximum distance, which is 1,412.67, so that we could have where our graph is supposed to stop. So looking at the numbers for our distance, we need to go from 0 to 1,000. If we look at the bottom here, to get to 1,000, it would be good probably to count by 100, because 100 would get me at least halfway through, and then I'd probably also be able to fit this 1,412.67. So I'm going to go ahead and write on every box 100, 200, 300, 400. My distance will go down here because this is our input, and our distance is in feet. So I'm going to pause the video and write out the 100, so go ahead and do that, and then check back in. Alright, so filling out 100, I started at 100, I got all the way up to 1,500, and I didn't even use the last box. So we'll be good with going by hundreds. 1,000 would get us to here, so we'll use more than half the graph. It's good to stretch it out. And I also can fit my max distance, so that's good. For the speed, it's going to go on this side. Our numbers go from 0 to about 217, so we want to make sure that we end somewhere around 200. So speed will go here. That is our output. And so there's about 16 boxes. Counting by 10s probably wouldn't be enough because I'd only get to 160. Counting by 20s would get me to 320, so I could do that. But maybe I might want to do like 15 in between, and do like 15, 30, 45, 60, and so on all the way up to the top. That way I can get a little bit more spread out and closer to what my max numbers are here. So I'm going to pause the video and do that, and then you can do it yourself and then check back with us. Alright, so counting by 15s, I was able to start at 15, and using all the way to the top, I got 240 as my last one. If the numbers that we're going by are numbers that you're not familiar with counting by, just use a calculator and just do like 60 plus 15, then you get 75. Then do plus 15 again to get your next number to help you figure out the numbers, because sometimes they're not easy numbers to just quickly add in your head. That's how I figure out these numbers. Sometimes I use a calculator. Alright, to graph our graph, we will need to graph 0, 0, which will be right here where our x and y axis cross. And then as I start graphing, I'm just going to approximate. The numbers are decimals here, so I'm going to try to get as close as I can to around where 58 would go. For 100, 58 would go just below 60, so I'm going to put a point right about here. I can't be super accurate, but I can decide if I'm halfway in the box or above or below that, and so that's, or like, am I close to the top number? So just try to use those ideas to make your points.
281 will be here and just maybe a third of the way up the box here, past 75. 300 and 100 I can do exactly. Oh, I can't because I don't have 100, but it's close to 105, so it'll be up here in the top third of the box. I don't have 400. 500 is 129, which is about 130. So let's see, I can get, that's probably like above halfway for this box, closer to 135. 800 goes to 163, which is just below 165. And 1,000 goes to 182, which is just above 180. And then our max point is 1,412, so that's going to be just past this 1,400, and then up, and then between 210 and 225, it'll be like maybe a little less than halfway, around the halfway mark. Yeah, probably around the halfway mark, so about there. So this is our max, which is 1412.67, comma 217. So when I go to connect my points, I can't go past this with an arrow. I have to stop there. So I may have to make my dots a little bit bigger because I'm afraid that when I connect my points, you'll lose them. We're just going to do a quick soft sketch, connecting them, looking at the pattern that we see. It's increasing. Some places it's increasing faster than others. Some places it's flatter, some places it's steeper, so something like that. And at this part, just don't connect them with straight segments because it is kind of increasing. And there are numbers between 0 and 100 that we didn't include here. So it's going to kind of curve. I'm going to try to smooth it out and then stop here. All right, the next task that we have, if we look at question 8, is going to be to describe the features. So pause the video, come back to your graph, describe the domain, the range, the intercepts, the maximums, the minimums, any intervals of increase or decrease. Write all your answers here and then unpause to check. Give yourself an opportunity to actually do it before just writing down the answers, because that will get your brain thinking and engaged and help you learn things and keep them in your long-term memory. Okay, so if we're going to look at the domain of our graph, we're going to look at where it starts, coming in from the left side. It starts at 0, and it continues all the way up until this point, which for my x is 1,412.62. So my domain goes from 0 to 1,412.67. We're including that number as our maximum distance, and we're including 0 as our minimum distance, so they both get square brackets. Looking at the range, I'm going to start at the bottom. The lowest it has is 0. The highest it has, it goes all the way up to the top. The highest is our max speed, which is 217. So when I write this one, it's going to be from 0 to 217. And we're going to include both of those because your car can go 0 miles per hour and this car can go 217 miles per hour. And it can go any speed between those as well. That's why we use this interval notation instead of just listing out discrete values. For intercepts, is it intercepting the y-axis or the x-axis? Actually, it's intercepting both right here at 0, 0. So we just put the point of intersection. Maximum, we would just put a point. So our maximum point is actually this point up here where we stopped our graph. So that's 1,412.67, comma 217. And then our minimum point is the lowest point on our graph, which is 0, 0. And then intervals of increase and decrease. If we look at the graph, it's starting at 0, 0. It's going up. Going up. So it's going up quickly here. It's going up a little less quickly, kind of flattening out, but still increasing as I go all the way to the end. So it's increasing from 0 all the way up to 217. So it's increasing over our entire domain. So from 0 all the way to 217. And I'm just going to add a note here. It's never decreasing. No, it's never constant either. Constant would mean it's not increasing or decreasing. But I'm going to note that it's never decreasing. All right. The next thing that we're going to do is we are going to look at comparing our two graphs. So if you take a look at this graph, in the graph that we made back in number 3, I want you to take a look at the two graphs. I want you to write down something that you notice about how they compare to each other. So you're comparing the two graphs, writing down something that you notice. And then what is the relationship between the two functions, s of d and d of s? So pause the video, jot down two things that you notice, and then what do you think the relationship is between the two, and then unpause and come back to check your answers.